Hello, welcome. In this video, we're going to do some more closure properties of regular languages, mainly intersection. So let's review what the concept of closure is. A set is closed under some operation if the operation on members of the set produces a member of the set. So regular languages are a set of languages, and if you perform any of these operations, union, intersection, complement, reverse, concatenation, star closure, positive closure, if you perform any of these operations on regular language, the resulting language is also a regular language. So that's why regular languages are closed under these set operations. All right, so let's review what we did before. We used this procedure Bob to demonstrate some of the closure properties. Procedure Bob is just a made-up name. It doesn't actually exist. It's just a procedure to convert a DFA to an NFA with one accepting state. So you have one initial state and one accepting state, and after you've performed procedure Bob on a couple of DFAs, then you can use that to demonstrate some closure properties. One of those that you can demonstrate is union. And in the other video, I showed some other ways that you can use procedure Bob to demonstrate closure properties of regular languages. It's not that easy to demonstrate the closure property of intersection. So intersection is more complicated, and you can also use this technique for union, but there are easier ways to do it. But to show the closure property of regular languages of intersection, you need to create the cross product of two DFAs. Remember that the definition of a regular language is that there exists a DFA or NFA, and you know that if there exists an NFA, there exists a DFA. So that's the definition of a regular language, is that there exists a DFA for that language. So if you make the cross product of two DFAs, like Q0, P0, Q0, P1, Q0, P2, etc., after you create the cross product of the two DFAs, if one of the states is accepting, for example, if you look at this, the first one here, we have the cross product, Q1 is accepting and P2 is accepting. So in the cross product, if you have Q1 and P0, if you are doing the union, then Q1, P0, that's Q1, P0. If that's accepting, if one of them is accepting, then it will be accepting in the cross product. For intersection, the only accepting state in intersection is going to be Q1, P2, Q1, P2, because in order to have an accepting state, they both must be accepting for intersection. So I'll repeat, you can do the cross product of Q and P. You have two DFAs. This is a regular language and this is a regular language. You perform the cross product. Once you perform the cross product of these two DFAs, which I'm going to show you the technique to do that, if you have one accepting state, then if one out of the cross product is accepting, then the new state and the new cross product DFA is accepting, but they both must be accepting for intersection. All right, so let's get started. Let's review how the transition functions work in a DFA. So on our first DFA here, we have our initial state is Q0. With an A, you go to Q1. So you're in Q0 with an A, then you're going to go and stay in Q0. I just said Q1, but I meant Q0. So Q0 with an A, you're going to stay in Q0. Q0 with a B, you're going to go to Q1. So I don't need to have this all marked up. And if you're in Q1 with an A, you're going to go to Q2. If you're in Q1 with a B, you're going to go to Q2. Q2 with an A, you're going to stay in Q2. Q2 with a B, you're going to stay in Q2. So these are the transition functions for this DFA. This DFA accepts the language any number of A's followed by a B. The second DFA down here will do those transition functions. If you're in P0 with an A, you go to P1. P0 with a B, you go to P3. P1 with an A, you go to P3. P1 with a B, you go to P2. P2 with an A, you stay in P2. P2 with a B, you stay in P2. P3 with an A, you stay in P3, and P3 with a B, you stay in P3. So these are the transition functions for these two DFAs. This DFA starts with an A and a B, followed by any number of A's and B's. And this one starts with any number of A's and ends with a B. So those are the two DFAs for the two different languages, and now we're going to go over how to do the cross product. When you're doing the cross product, you don't want to deal with all of the states. You only want to deal with the accessible states. So there are some states that you're never going to get to, so there isn't any reason to consider those in the cross product DFA. So you start with your first state, Q0, P0. So you have Q0, you have P0. Q0, P0. Q0 with an A is going to stay in Q0. P0 with an A is going to go to P1. So I'm just going to go quickly through this, and then I'm going to go each one slowly one by one. So we have Q0, P0, then we have Q0, P1, because we went to Q0, P1, so the next one to consider is Q0, P1. Then the next one to consider will be Q1, P3, Q1, P3. Then the next one to consider will be Q0, P3. Then the next one to consider will be Q1, P2. Then the next one to consider will be Q2, P3. Then the next one to consider will be Q0, P3. All right, so why didn't we do Q0, P3 again? Because we've already done Q0, P3. Then the next one, Q1, P3. We've already done Q1, P3. So the next one is Q2, P2. And now we're going to one by one go through what I just showed you. So we start out with Q0, P0. That's our joint initial state, Q0, P0, with an A. Q0 stays in Q0. And P0 with an A is going to go to P1. So the first transition is these two states combine Q0, P0, what combined state do they go to with an A? And the combined state they go to with an A is Q0, P1. Then we go to the next one. Q0, P0, we just did an A, so now we're going to do Q0, P0 with a B. Q0 with a B goes to Q1, and P0 with a B goes to P3. So now the next one we want to consider is Q0, P1, because that's an accessible state. We've been able to reach Q0, P1, and we're just going to go through until we have reached all of the cross product accessible states. There isn't any reason to consider any states that we don't ever get to. So you don't want to go ahead and write all of the different combinations. You just keep going until you've reached all of the ones that are accessible. So the next accessible state is Q0, P1. Q0, P1 with an A goes to Q0, and P1 with an A goes to P3. Then we have Q0, P1 with a B. Q0 with a B goes to Q1. P1 with a B goes to P2. All right, so now we've already done this state. That was our next accessible state. So the next accessible state we're going to consider is Q1, P3. Q1, P3, Q1 with an A goes to Q2. P3 with an A goes to P3. Then we have a B. Q1, P3 with a B goes to Q2, P3. So we just did this accessible state is done. And now the next accessible state we did was Q1, P3. And now the next one we're going to consider is Q0, P3. Q0, P3, Q0 with an A goes back to Q0. P3 with an A goes back to P3. Then we do it with a B. Q0, P3, Q0, P3 with a B goes to Q1, P3. Q0 with a B goes to Q1. P3 with a B stays in P3. So we've done Q0, P0, which was our first state, we've done Q0, P1, we've done Q1, P3. So Q0, P1 we did, Q1, P3 we did, Q0, P3 is the next one. So now the next one we're going to consider is Q1, P2. Q1, P2. Q1 with an A goes to Q2. P2 with an A stays in P2. Q1, P2 with a B. You can also follow the transitions over here. That's fine too. Q1, P2 with a B. Q1 with a B goes to Q2. And P2 with a B stays in P2. So we've done Q1, P0, Q1, P3, Q0, P3, Q1, P2. The next one to consider is Q2, P3. Q2, P3. Q2 with an A goes back to Q2, P3 goes back to P3, and so we have Q2, P3 goes to Q2, P3, and with a B it also goes to Q2, P3. So we've done our initial state Q0, P0, which has, from our initial state we were able to get to Q0, P1. So we did Q0, P1. Also from our initial state, we could get to Q1, P3. So we did Q1, P3. Then we got to Q0, P3. So we did Q0, P3. Then we got to Q1, P2. We did Q1, P2. Then we got to Q2, P3. So we've done that state, which goes back to the same state. So we've already done Q2, P3. We've already done Q0, P3. We've already done Q1, P3. So the next state we're going to consider is Q2, P2. Whoops. Q2, P2 is the next one we're going to consider. So from Q2 with an A, you stay in Q2. From oh, dang it. Oh, we've already done that. We've already done that. We've already done that. Okay, sorry. Q2, P2. Q2 with an A, you're going to stay in Q2. P2 with an A, you're going to stay in P2. And the same thing with a B. So now every state that has been an accessible state from where we started at our combined Q0, P0, we have now satisfied all accessible states. So these are going to be the states for our new DFA. We don't need to consider states that we never reached, like we've never reached Q0. Let's see, we got Q0, P0, Q0, P1. What about Q0, P2? I don't think we ever reached Q0, P2. So Q0, P2 is not considered an accessible state. So once we've written up all of our transition functions, now we can decide from that if we have our combined states. So we have Q0, P0, etc. So of these combined, the Q0, P0 is going to be our initial state for our DFA. Our new DFA is going to be the same, but then we can decide on which ones are going to be accepting and which ones are not. So for intersection, the only accepting state is going to be Q1, P2. So Q1, P2 right here, that's the only state that can be accepting. But with union, so this is intersection, with union, we can have multiple accepting states. All right, so next we're going to draw our new DFA. All right, so here I'm just going over what would be the accepting states for intersection and which could be the accepting states for union. Now we're going to draw our new DFA. So our new DFA, instead of naming this state Q0, P0, I'm just taking the numbers. So the Q is always going to be the first number. So this is 0, 0. So this state Q0, P1 is going to be 0, 1. This one's going to be 1, 3. So we started our initial state, which is 0, 0. With an A, we will go to 0, 1. With a B, we will go to 1, 3. Now we start from 0, 1 and decide where we're going to go. 0, 1 with an A, we're going to go to 0, 3. With a B, we're going to go to 1, 2. And these are just the same transition functions that were defined in the previous slide. Now we go to the next one, which is 1, 3, because we started here, we did 0, 1, now we do 1, 3. With an A and a B, we go to 2, 3. And now we go over here to 0, 3. With an A, we're going to stay in 0, 3, and with a B, we're going to go back to 1, 3. And now we go to 1, 2. With an A, we go to 2, 2, and with a B, we go to 2, 2. And now we go from 2, 3. With an A or B, we stay in 2, 3. And this state right here, with an A or a B, we stay in 2, 2. So now we just took the transition functions from our first two DFAs, did the cross product, created our new transition functions only for accessible states, and now we have drawn our new DFA. And now we need to decide which ones are going to be accepting in the new DFA and which ones are not going to be accepting. And that depends on whether or not we're doing the intersection or we're doing the union. So going through the states again, 0, 0. With an A, we go to 0, 1. With a B, we go to 1, 3. With a B, we go to 0, 3. Then we have our state 1, 2. We have our state 2, 3. And we have our state 2, 2. All right, so now with intersection, the only one that could be accepting is going to be 1, 2, because both of them need to be accepting in order for it to be accepting, and our initial state is 0, 0. For union, well, that's intersection. For union, we have more than one accepting state. So 1, 0 would be an accepting state, except that there is no state 1, 0, so that's not an accessible state. Q1 combined with P0, that's not an accessible state, so that doesn't even matter. The next one we have is 1, 1. 1, 1 is also not an acceptable state, so that, is not an accessible state, so that one's not going to be accepting. The next one we have is 0, 2. 0, 2 is also not an accessible state, so none of those states even matter because we never got there. But the accepting states for the union would be 1, 2, which is this one right here, 1, 3, which is this one right here, and 2, 2, which is this one right here, and we of course have our same initial state. So what does that mean? It means that we've constructed the cross product of the two DFAs. If both of those states are accepting, then that's the intersection, and if one of them is accepting, that's the union. And because we were able to take two DFAs and show that the intersection of the two DFAs is also a DFA, then we are demonstrating that regular languages are closed under the operation of intersection. All right, and also we are demonstrating that regular languages are closed under union, but there's a better way to do that. So here's just a review of the 5-tuple representations of the closure properties of regular languages. So DFAs are represented by a 5-tuple, where Q is the set of states, sigma is the alphabet, this represents the transition function, this is the initial state, and this is the set of final states. But our language 2, we're going to represent our DFA. Instead of the states being Q, the states are going to be P, and so our initial state is going to be P0. So this is just a 5-tuple representation of two languages. The 5-tuple representation of the complement of language 1. So we don't need two languages to do the complement. You still have your same states, your same alphabet, you have a transition function, you have your initial state. only your set of final states, instead of being the set of final states, it's going to be your set of states minus those that were previously accepting. So that's the complement. The union, for the union, we're going to create an NFA, which of course could then be changed into a DFA. So you're going to have all of your states are going to be the union of your states of your first DFA, union with the states of the second DFA. You also have a new initial state. You have your same alphabet. You have a transition function, your new initial state, which has a lambda transition to the previous initial states. And then your final states are going to be the union of all of the accepting states. This is not doing procedure Bob. This is just a 5-tuple where you just have a new initial state with lambda transitions. The intersection is a little bit more complicated, but after doing the cross product, you should probably be able to understand this. You have your set of states crossed with your other set of states, your alphabet, your transition function. Your initial state is going to be the two initial states, and then your set of accepting states are going to be made up of a state from Q and a state from P, such that Q is an accepting state and the P state is also an accepting state. And then this is just a long explanation of how you do the transition functions.